Okay, welcome back. We're doing some more differentials. Quite a big session this one, isn't it? In preparation for StuBack, giving you lots of practice and lots of explanation so that you can do practice on your own. All right, so here we've got differentiate the following, and this is a combination, isn't it? I like these. I must tell you that I like these, and the reason that I like them is because they're more representative of what you'll experience in Math 1. The other ones are just like a little bit of high school practice, but see this one here, ooh, I like that one. And this one here, ooh, they're good value. This has got a couple in it as well. So these are much more like what you'll get in Math 1. So I'm really pleased to be a part of this particular set. All right, now I know that I wrote up before U to V, V to U, and you might have learned it another way, and that's okay. Y dash, so I just swap them around, so we get V to U minus U to V over V squared. Now, whether you do it that way or the way that I put up earlier, doesn't matter. It's the same difference. Okay, so this one here on the way they're expressed is that so that they're the same. They're expressed so that they're the same, and all you do is change that. And that's fine. If you want to learn it that way, that's fine. All right, so let's do this one. U, V. So this is awesome because we've got, better draw. Do some drawing on this one. So fitting. So what we've got is y equals the square root. Now this one here is a quotient rule, isn't it? Not easy to pull there and factorise. So I'm going to use m and n, and I'll explain that in a little while. So my version of this quotient rule will look like m n minus n m over m squared. That'll be my version. So if that's m, now look what happened. N dash is equal to 1. It couldn't be easier. So we've got two values for n and n dash, so that's great. But look at this one. M is equal to, now I can do this now because I know that you're familiar with the indices. It's becoming much easier for you to process. Now this is a function of a function. In other words, it's a chain rule, a function of a function. So it needs me to write this as let u. If I'd used u like we did up here, I'd be confused now. I'd have to use m. So either way, it doesn't matter. But you've got to get used to substituting pronumerals of different forms. So f of x, or f of u, is 5x plus 1. I can rewrite m in terms of u. So the m du, so this get our scaffolding right, the u dx means that our dm dx, because this is what we're after, remember, our dm dx, in actual fact this one could probably be a bit smaller, couldn't it, this time, because I'm working off here more readily. Didn't like that, so I'll fix this one up and take that one in a bit more. That's better. So then we've got the m dx, so m dash is equal to the m dx, and we're still going to have that. We're just going to go through dm du dx. So it always works, doesn't it? Now look at all the scaffolding, look at all that laying out, look at all the thinking, the preparation. That's got to become autonomous for you in Maths 1. There's no dilly-dallying in Maths 1. There's not going to be any time to think about, oh, I've got to do this. You've just got to do it. Because the other thing is the thing that you're learning. Whatever you're learning that's applying this technique, it's not going to be about this. It's going to be about some other thing. So we need to be able to put these together fairly fluently, please. So let's do the calculus. Half comes out, u, half minus 1, not a big deal. This one here is just going to be 5. Let's refine this a bit further. Half minus 1 is minus a half. Minus a half is going to pull that u down. So we're going to get 2 minus a half u. So we can put them together now. 1 over, now put the x back in. It's random when you do that. The u was 5x plus 1 times 5. So we get a final m dash of 5 over. So all we did there was work out m dash. Okay, m dash, this one. That's all we did, one term. But look how much work we had to do. That's not fair, it seems, isn't it? So when you come to do these, it's very important that you understand that process, okay? So we're going to put m n dash, which was 1, so that's just like square root 5x plus 1, so that's one part, okay? The second part is n dash, which we worked out was 1, so that's nothing. So then we've got to have n, which is x, times everything that we put up here. So we're going to have this times x. So we're going to have x, 5x, over 2 root 5x plus 1. Okay, now what was the difference there? I left the minus out. Don't leave the minus out. And then on top of there, we're going to put x squared. So that's that one. All right. Now we can clear these. Yesterday I didn't do that, but we can make these the same, because what it would mean is that we would have to multiply by, we could get the fractions out and multiply through by 2 root x. To make them the same family, we would need to multiply by this one by 1. So 2 root 5x plus 1 and 2 root 5x plus 1. Now that'll be the same family now. And so then we'll have 5x plus 1 squared. Oh, so that means that that's going to go, but the 2 will stay. So we're going to end up with two lots of 5x plus 1 on there over 2 root 5x plus 1 minus 5x over 2 root 5x. So we've made the denominators the same for both sets, not just this one, but for both sets. And then on top of that, we've got x squared. So x squared we can bring out as a product, which will kind of soften the look of this quite a bit. Now, if I put this on the same denominator, we'll have 2 5x plus 1 minus 5x over, same family, 2 root 5x plus 1, and then times 1 over x squared. That just makes it look a bit softer, doesn't it? So then we can do our little expansions, and we can do some rationalising on the bottom. So we get 2x squared. So let's do this one. So we get 10x plus 2 minus 5x over 2x squared, square root of 5x plus 1, which will be 5x plus 2 over 2x squared, square root of 5x plus 1. Looks like a rather complicated set, doesn't it? But in reality, what it's doing is showing you how to do all of your mechanics, all of your parts. So apart from the algebraic gymnastics, what we've got to recognise is that we've also got our chain rule now. We've got our chain rule we've got to deal with. Okay, so that's the top one, and the bottom one's just x. Let's have a look and see what that looks like. So what have we got? Square root of 5x plus 1, so that's the one that we wanted, over x. Do that with our derivatives, so at either point we get looking very similar, don't we, in expanded form. So I'm pretty happy with the way that's going. So I'm just going to sign in here. Just going to check this. Don't do that to me. Oops. Alright, let's not bother with that. I don't remember it, to be honest. So just don't worry about it at this point. I'll play with that later. I'll have to get my phone. Alright, so we can use our validate check to go and check those things. Okay, so those are worth doing because it teaches you how to do it. This is a hard page, I know it. I get that, okay? I understand it. Okay, I understand it's a hard page. This page is worth doing for Maths 1. Alright, worth doing for Maths 1 in spades. Let's have a look at the other version. The way the chain rule set at the top when we went that very beginning. So the chain rule at the very top. So we had the product rule as y dash equals u dash b plus a b dash u, and the other one, that was the product rule. The quotient rule is u dash. Same, you see, that's the bit it likes. The reason they teach that at school. Now it impacts on your science. That's the reason that I'm showing you this. Okay. So on this side here, we'll do 2, and we'll do it the old-fashioned way. X plus 1, choosing u and v. Okay. U and v. So u dash would be equal to 1, and v dash is equal to, aha! So we've got to let u equal, no, I'd used u. So we've got to choose another pronumeral, let m equal. Now we're using m for the chain rule. This might be easier than what I did previously. Let m equal 9x plus 1. So we can rewrite this one in terms of v equaling m squared. Okay, v was m squared. So now we can do dv dm. See, we're pulling up all these differentials that look different, but they're not. dm dx, because they're going to go together to give us our v dash. This is 2m, and this is simply 9. How quick was the calculus? Calculus is not the problem. Okay, so v dash is dv dx, which is going to be dv dm, dm dx. We're still going to have dv dx. So now it's 9 times 2m, which is 18 9x plus 1. Now it's a simple expansion. So we can actually do an expansion if you want to. 18 nines. 9 8 to 72. 9 1 to 9. 162. So 162x plus 18. So then when we come to put our quotient rule together, we can say y dash is equal to u dash times v minus v dash times u divided by 9x plus 1 squared. Don't forget that's this part in operation. So it's a squared. So we can do some quick 9x plus 1. Now I'll keep these in brackets. 162x squared plus 162x plus 18x plus 18. Now we've got a 4 because they multiply, don't they? So 9x plus 1. So we've got 9x plus 1. Now we've got anything we can join together here. 162, 172, 180x. 180x positive. So I'm going to do this little expansion across these three terms now. So we'll get minus 162x squared minus 180x minus 18 all over 9x plus 1, 4. And so 162x squared now minus 180 plus 9 171 minus 18 plus 1 Do we need to solve the quadratic? It depends. It depends on the question. Do we want it in factorised form? It just says differentiate, so we finish differentiating up here actually. So I would give that full marks. I would be happy with that. But this now is just your gymnastics, isn't it? Just gymnastics. So we could solve that. We could solve that quite readily. And that might be the case too. Right. So I just want to do the all from one, and so I'll quickly put that up for you. And okay, so that's an understanding. So I'm just getting his password in. Very good. So that's updated me. Gave me what I wanted. I'll bring this back here now, put it into this tab here. There we go. And then you can go through and do show all your steps. And that's if you get a subscription. Teachers that are learning at university are getting those now because they're able to do that. But as students, you can do that, but it means an extra expenditure. And here's your little rule. Look at your little rule. Here it is. Here's your little quotient rule in action. See, dB dx, dB dx u. So that's the rule that they're using. So that's why they came out with their plus and minuses. But it ostensibly gets the same thing. So that's pretty cool. So I'm going to stick to using it the way I'm convinced of that now. So that's fine. Oh, we didn't put it in. So I better do that. Go back up here. And what did we have? On the top we had x plus 1. And on the bottom we had divide by, open a bracket, and what do we have? 9 plus x, 9x plus 1. Close the bracket, raise it to about 2. Let's see what that looks like. See if it's the original question. X plus 1 over 9, x plus 1 squared, x plus 1, 9, x plus 1 all squared. Very good. Okay. And so it's actually gone ahead and factorised. It's actually factorised the quadratic, which is hilarious, and which means that one of these 9x plus 1s cancelled. So that's quite funny. The more complicated these get in terms of their gymnastics, it doesn't mean that it's an incorrect answer. It just means that now what I can do, what can you do then? If you're going to waste time, it's running out of video time. And you've only done 2 questions, so I'll just prove something here. I'll just see if I can do this. So we're going to have 9x plus 1, because I made a comment there about them being correct. So we're going to go here, we're going to go 9x. I did not go a bit easier on that. Yeah, minus 162x. X squared minus 171x minus 17. So that's the top, that's the bottom. Let's see what it says about that. Might not like that. Minus 162x squared minus 17, 9x plus 1, 4. Let's take one off. No, I really wanted the Boolean answer for that. Alright, let's just leave that for the moment. But we could just take these. I love mucking around with this stuff, isn't it fun? Honestly, it's just a lot of fun. Now we'll just take this one because I've got this here now. Take this off. There's a 9x plus 1 there. See that? So that cancels. One of those will cancel. And so that lends us towards this result that we got here. Okay. Now that now look, that's differentiating the whole thing. So I think what I have to do is put that there. See what that looks like, because that's differentiating the whole thing. Which is not really what I wanted. With respect to all of that, so let's put that around everything. A bit stubborn, don't I? Okay, so let's leave that and I'll do another demo for that. Alright, it's 22 minutes. I'm going to pause this video and come back and do this one. And yeah, we're on our way.